When we talk flood management, we have a system that we're actually talking about. We're talking about dams, we're talking about levees, then there's bypasses, and this system works together. What we're trying to do is we're actually trying to manage the risk of flooding. And one of the things about risk, I think it's very confusing for a lot of people. What is risk? We all live with different kinds of risks. When you wake up in the morning and you get in your car, there's a risk of getting in an accident and having your car damaged. That's a risk. When we talk about flood management, there's a risk of flooding. A lot of things could happen, both in the streets, just normal small local flooding, to large flooding by overtopping or failing of levees and things like that. So when we think about risk, we really think about it in two components. As simple as it could be explained, risk is the probability of something happening times the consequence if that were happening. And so the probability piece is really misunderstood. And when we talk about flood management especially, we talk about things like 1 in a 100-year flood or 1 in 200-year flood. And that's a bit misleading. And us engineers, I think, help with that misunderstanding by using those types of terms. But what is a 1 in a 100-year flood? A 1 in a 100-year flood, it only means that there is a 1 in a 100 chance of something occurring in a year. And if you want to kind of correlate that to something more simple, kind of think of a roulette wheel. A roulette wheel has 36 numbers, and then it has a 0 and a double 0. So that roulette wheel has 38 different slots that marble can slot into. So when you spin the roulette wheel and you throw that marble in there, it could actually fall on any one of those numbers, and the chances of that occurring each time you spin it is 1 in 38. Well, flooding is the same thing. In any one year, there is a 1 in a 100 chance of a flood that big or bigger actually occurring. And so when we talk about 1 in a 100 year, that doesn't mean this flood is going to happen once every 100 years. It could actually happen twice in 100 years, or 3 times in 100 years, or never in 100 years. Only think of it as there is a probability of it happening one time in 100 chances of it occurring. So that's the probability piece. And then the consequence piece is what's going to happen. And so as the consequence gets bigger, or the probability gets bigger, the risk gets bigger. And so as flood managers, we need to try to work on both sides of the equations, and that's what we do. And so when we've improved the levees, the probability of the failure of that levee has significantly reduced with a lot of the great work that Yuba Water agencies and others have done to reduce the probability of the failure of that levee. When we talk about the dams, how do they help us with probability? Well, what they're doing is they're actually helping to control the floodwaters. So as the water comes into a reservoir, it's stored, and it's stored for a partial amount of time before it starts releasing. And with these large reservoirs like New Bullard's Bar Dam, you could release less water than actually is coming in. And what us engineers call that is kind of knocking off the peak. It's knocking off that peak flow, so the system below and that levee could actually handle that amount of flow. So again, these things are working in tandem. The reservoir is working with the levees to manage that flood going through your system. Now, when we talk about consequences, the consequences are always changing as well. So what is behind the levee? If a failure occurs, there's a lot of folks that live behind levees. There is a lot of homes, and that's constantly changing. Sometimes more people are actually living behind the levees than maybe there were 50 years ago, and maybe there's going to be more in the future. So the consequences is increasing. So the overall risk is increasing. So as flood managers, we always have to be doing what we can do to reduce the total risk. And we need to continue to think about that in the future with smart ways, financially smart things that we can do to reduce the risk, either on either side of the equation, either the consequence piece by making sure we're building in really smart areas, or the probability piece, reducing the risk of levee failure, reducing the water level within the river. So in any sense of the way, that's what we need to do in the future, and we need to continue to do that for the future.